Hey guys, how you all doing? It's Jalajura here again, back with another video from B Gem at GCSE Chem, and today we're going to be doing section C3.10, which is all about which is called Giant Metallic Structures. So this is going to look at both metals and alloys. So the book I'm using is again I'm using the GCSE AQA GCSE Chemistry Caboodle book, which is the revision guide that I'm using, and So again, this is the book that I'm using. It's the red book, and again, I've got my fan on. It's really hot where I am, so it's extremely hot. So I just need to stay cool, That's why. And also, I just want to say a couple of other things before we start. Again, I haven't been able to put the links to my websites. I've been saying this for so long now. I'll try and do it by today again, because the thing is, when I do get time. It takes me because I've already put the titles of the videos and stuff, so it only takes me 5 to 7 minutes to put the links to 10 sections, or not 10 but 8 sections. So it's not going to take me much time at all when I do start, and I'll try and do it by today. Just looking at the notification there, but on my phone. But so I'll try and do it by today, try and update everything by today, from C3.2 to C3.9, because they're the sections, and C3.10 after I've done it today, obviously after I've uploaded it on my YouTube channel. I'll try and put all those sections on my the links to all those sections on my website. And also, it's my friend's birthday today, so I'd like to wish him happy birthday. And my friend's called Bars. He really supports my channel. He's a really frequent viewer of my channel, and he supports me a lot, and he's a really good person. So I just want to wish you a happy birthday, man. If you're going to watch, you probably are going to watch my videos. You're really supportive of them. You support them a lot. So you're just a great friend, and I hope you had a great day, man, today. And just happy birthday, I guess. Hope you had a nice day. And also hope you had a good day out with your family, because obviously he was going out with his family for his birthday. So hopefully that was good. And another few things, I think a couple of things, is also obviously A-level results day. Sorry about the noise, background noise there if you can hear it. But also A-level results day is on 13th of August. So obviously good luck to everyone who's receiving their A-level results. I hope everything goes well for all of you. And then on the 20th of August, both are on Thursday, by the way. So A-level results day this Thursday, and then GCSE results day, which is next Thursday. So GCSE students, I wish them the best of luck as well. But basically, just wanted to tell you, on the 20th of August, I won't be uploading a chemistry section video, like a teaching video. Instead, what I'll be uploading is a video on should you take A-level chemistry, and the benefits, the reasons why I believe you should take A-level chemistry, and is A-level chemistry for you. And sorry if you can hear any noise again to the notification, but there you go, from my from someone's phone. It's not my phone, but so I'll be basically going through all of that. Should you take A-level chemistry? Is A-level chemistry for you? Why you should take A-level chemistry? Because basically, obviously, many people will be receiving their GCSE results, and some people might say, I'm stuck between maybe picking chemistry or physics as my final option. For example, it's like that. Obviously, I do physics A-level as well, so I'm not going to say bad about physics, obviously, but I'm just going to say, for example, if they're for example, choosing between maybe if people choosing between if there's, for example, if they are maths, physics, and they want to do something like, I don't know, psychology, and they're choosing between psychology and chemistry, I'd obviously recommend chemistry, and I'll tell you the reasons for that as well. But basically, I won't be saying any subject is bad, obviously, but I'll tell you my views on why you should take A-level chemistry. So hopefully that makes sense, and that's the video I'll be making on the 20th of August 2020. So next Thursday I'll be making that video. And so today, so that's what that video is going to be about. So it's not going to be a topic video, basically. We're not going to be going through any chemistry in that time. We're going to be talking about A-level chemistry, but we're not going to be talking about we're going to be talking about chemistry, but it's not going to be kind of content Hopefully that makes sense. And so today we're doing C3.10 Giant Metallic Structures, and if you're following the student book, which is obviously the big textbook, it's pages 54 to 55. What I have recently, noticed that I have been able to say the pages now first time, on the first go, and not say it later on, which is a good improvement, I guess. But yeah, so C3.10 giant metallic structures. So let's begin. So the atoms in a pure metal are arranged in a closely packed layers. In closely packed layers in a giant metallic structure. We know that atoms in a pure metal, they're arranged in layers in a giant metallic structure. We know that. They're arranged in closely packed layers, because the layers are they're very closely packed together, and they have a regular arrangement, and the atoms have a regular arrangement, and they're closely packed layers basically, and in a giant metallic structure. And the layers of these atoms are obviously able to slide easily over each other, and that's actually the reason why metals can be bent and shaped, but pure metals are too soft for many uses. The thing is, pure metals are very, very soft. That's the thing, and so we can't really use them quite a lot of the time. They're too soft for many of the uses. Because basically metal atoms have layers. Metal atoms are arranged in basically layers. The layers of atoms, they're able to slide over each other. This makes the pure metals quite soft and for many uses, and obviously they can be bent into shapes, and they can be bent in shapes and stuff. But so hopefully that makes sense. So sometimes pure metals aren't very useful because of the fact that they're too soft, and their layers can slide about. Now we're looking at alloys. So alloys, I mentioned before we're talking about alloys. So what are alloys? Well, alloys are mixtures of metals or metals with other elements. So it's basically, it has to be a metal with something, or it could be a mixture of metals. Hopefully that makes sense. And these, the different sized atoms in the mixture distort the regular pattern of the atoms in the layer of the metal structure. Now remember, in a pure metal, like for example pure iron, which I'll show you a diagram of in a minute, but basically in pure iron you're only going to have iron atoms. So you're only going to have iron, I think it's better to say iron in it. So you're only going to have iron atoms in pure iron metal. So that means you only have, the atoms are only, a specific size. They're all the same size, and this means that their atoms can slide about. The layers, the layers of the atoms can slide about, and that's why pure iron is softer than an iron alloy. So an iron alloy can be more useful. But what an alloy is, basically, it's a mixture of metals, or it's a mixture of metals with other elements, basically. Or it's metals with other elements. And basically, because they're metals with other elements, or it's a mixture of metals, it means you have differently sized atoms, basically. It's not it's not all the same size. So that means it distorts the kind of so here it says it distorts different sized atoms. The different sized atoms in the mixture distort the regular pattern of the atoms in the layers of the metal structure. So they distort this regular pattern of the atoms in the layers. So this means that these atoms, this makes it very difficult for the layers of the atoms to slide about, because obviously the layers of the atoms can now no longer slide over each other, because they're all different sized. They all have different sizes. The atoms have different sizes. So and this means that's the reason actually why so it's difficult for the layers of atoms to slide over each other, and that's the reason. So as a result, alloys are harder than pure metals. So hopefully that makes sense, and I'll actually show it to you with a diagram. Here there are two diagrams. So here's pure iron. So here it says pure iron. You can see it only has iron atoms, and they're all the same size. So you can see that the atoms will be able to slide over each other because they're all the same size. Now here you have an iron alloy. So iron alloy, it is iron alloy. You can see obviously that here you have iron, but then here on green you have something else. So these are different sizes, and these different sizes basically distort the regular arrangement and make it difficult for the layers of the atoms to basically slide about. And that's why alloys are harder and much more useful actually than pure metals. So that's an iron. That's pure iron with just iron atoms. That's an iron alloy with iron atoms and something else as well. So that's why for example, here iron alloy would be much more useful than pure iron. So hopefully that makes sense, because obviously it's much harder. So yeah, here in the orange it just says pure iron and iron alloy. Right, so then here's a question. So first question of 2 in this section is, why are alloys more useful than pure metals? Well, it's because obviously in alloys, they obviously have the distorted arrangement. They have different sized atoms which distort the regular arrangement of the atoms in the layers of the metal structure, which means that it's difficult for the layers of atoms to slide about in alloys than it is for in pure metals, because obviously in pure metals that they are all the same size, the atoms are all the same size, it's just pure one metal. So that's why they can slide about in pure metals, and therefore they're much softer and therefore they're much less useful. So let's see if my answer kind of goes along those lines. I'm pretty sure it would. It would be something along those lines. And because obviously metals, these pure metals can be bent into shapes, and so they're much softer and stuff like that. So let's see. So they are harder than pure metals. We've been through that. And so pure metals are soft, where alloys are much harder, and they can. It says another point here. If it's a 2-mark question, you should also add basically they can be made or designed to have a very specific or special properties, such as shape memory alloys. Now, shape memory alloys. What happens, for example, I believe it's in glasses actually, that if your glasses bend, they can actually come back to the original shape, and that's because of the shape memory alloys. I'm pretty sure that's what it means. I'll just make sure with my phone. I'll just make sure quickly, but I'm pretty sure that's what it is. But they could also be used in design of shape, like for example, wait. A minute. Yeah, they have elastic properties, which basically means they can return to their original shape, to what they were before, if they become bent, basically. So hopefully that makes sense. I think I've added everything there. So one was obviously about the fact that obviously they're harder than pure metals, are alloys, and they can be. And the next point was obviously, which I didn't mention, which wasn't actually in the book, but they can be made or designed to have specific or special properties. And you can give an example of shape memory alloys, for example in glasses. I don't know why I say sunglasses. I'm pretty sure it's in sunglasses too, but yeah, just say glasses. Or you could just say shape memory alloys. So hopefully that makes sense. And now we're looking at the next point, which has basically metals have high melting and boiling points. Now in the giant structure, the electrostatic forces of attraction between the positive metal ions and the delocalized electrons are extended in all directions. Therefore, a lot of energy is required to break down the lattice and separate the metal ions to form a liquid. Basically, yeah, we've been through this before actually. We know that metals have very high melting and boiling points, and basically in this giant lattice structure, basically metallic structure, what you have strong electrostatic forces of attraction between the positive metal ions and the kind of delocalized electrons, or you could say sea of delocalized electrons, and these act in all directions. And basically a lot of energy is required to overcome this very strong force of attraction, and therefore kind of break down the lattice and obviously separate the metal ions into a liquid. So hopefully that makes sense. We've been through actually this. I don't know if we've been through it in the I'm pretty sure we went through this actually. Yeah, we did go through this we didn't go through the fact that it conducts electricity in the last section, but we went through the fact that it has delocalized electrons which are attracted to the positive ions, and this is a strong electrostatic attraction. And basically, a lot of energy is required to break down the lattice and overcome this basically a very strong electrostatic force of attraction between these positive ions and the delocalized electrons. And this basically, a lot of energy is required to do this and separate the metal to form a liquid. Basically, separate the metal ions to form a liquid. So hopefully that makes sense. Metals are also good. Metals are good conductors of thermal energy and electricity. Now, the electrical charge and thermal energy are transferred quickly through the giant metallic structure by free moving delocalized electrons. Now that's important as well. So basically, you need to also know that metals are good conductors of thermal energy and electricity as well. And basically, the electrical charge and thermal energy are transferred quickly. Yeah, because of the the metals have these delocalized electrons, which obviously delocalized means they're free to move. It means that they can transfer the charge, and they can also transfer thermal energy throughout through the giant metallic lattice or giant metallic structure. They can, because these electrons are so powerful, that they can basically transfer thermal energy, and they could also transfer a charge quickly through the metal structure and to the giant metallic structure. And it's because of these free moving or delocalized electrons that they're able to do this. So they basically, you just need to know they have thermal, they are kind of good conductors of thermal energy and electricity as well. They have high melting and boiling points, and you should know the reasons for this as well, which we've just been through. And then here's the second question, which is the final question of the section. Why are metals good conductors of electricity? Well, we've been through that. They have delocalized electrons. Basically, metals have delocalized electrons, which can carry the charge basically, and transfer the charge through the giant metallic structure, and therefore, because of these delocalized electrons, it can basically carry the charge, and metals can therefore conduct electricity. So that's why that metals are good conductors of electricity. So that should be the answer again. Just looking through the book just to make sure I haven't missed anything out, but I don't think I have, but we'll just see. So delocalized electrons move rapidly through the metal structure. Yeah, basically I just said that. They have delocalized electrons which move through the structure very rapidly, basically move rapidly through the structure. So the key word in this section was just alloys, and the key points, just to finish off, are that metals can be bent and shaped because the layers of atoms or positive charge ions in giant metallic structure can slide over each other. We know metals, sorry about that, excuse me. We know that metals can be bent or shaped is because their layers of atoms can slide about, because obviously it's only once, the size is the same of all the atoms in the metal because it's pure basically, and the metals can therefore be bent and shaped, and they are much softer than alloys. We know that, and the layers of atoms can slide over each other. Now we also have the next section, next part of the key points, which is alloys are harder than pure metals because the regular layers in a pure metal are distorted by atoms of different sizes in an alloy. So basically, in an alloy, you have atoms of different sizes which distort this regular arrangement that is in a pure metal, but not in an alloy. So these layers can't. Therefore, it's very difficult for the layers of the atoms to slide about, and because the atoms are of different sizes in an alloy. So yeah, and then the last point is that delocalized electrons in metals enable electricity and thermal energy to be transferred through a metal easily. Again, we've been through that. Metals can transfer. They're good conductors of thermal energy and electricity, and we've been through why they can. They can transfer. They can transfer charge and thermal energy. They're delocalized electrons. They can transfer charge and thermal energy through the metal quite very easily. So that's basically it for this section. Next section is going to be C3. 3.11, so C3.11, which is on nanoparticles, and then C3.12, which is on applications of nanoparticles. Before we're done with this chapter. Now, if you're doing combined science, you can stop here. You can, because you don't need to watch the next two videos, because tomorrow and the day after tomorrow, unless you're obviously interested, because C3.11 and C3.12, which are the last two sections of this very big chapter 3, very big chapter. This has been, I think it's the biggest chapter in the book. I've mentioned this before, or the longest or biggest, I don't know how you say, but basically it's the it's basically the biggest chapter in the book. But the next two sections are only going to be for triple science students only, and I'll write TSS only just to specify on the title. And I'll that's the end of the section, guys. I'll try and put the links to the videos from C3.2 to C3.10 up on my website by today. And as I've told you about 20th of August, it won't be a kind of teaching video or go through content video. It'll be about A-level chemistry and should you pick it, because these are very important decisions, you know, that GCSE students have to make before going into school in September. So and obviously make sure to, hopefully it was very helpful, this section, hopefully this video was very helpful, and make sure to share, like and subscribe, and turn the notifications on, or turn the notification bell on, so if you haven't already, so you're notified and updated when I upload new videos that you can watch. And I think that's all I had to say. Again, happy birthday to you, Bars. Like, he's one of my great friends. Like, you know, hope you had a great day today. And I think that's it. So thank you very much, guys.